Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone and welcome back to another video in the series of machine learning with Scikit Learn. And today we'll be looking at the algorithm named as k-nearest neighbor. Now I'm pretty sure that if you have went through the machine learning courses or the overview, you must have heard about the k-nearest neighbor as being one of the most popular algorithms in machine learning. Now in today's session, we'll be looking at what is KNN, why it's known as one of the easiest and the lazy approach, why it's a specific name is given to that is the lazy approach, and let's see how one of the examples works for that. So the notebook is ready, and before understanding the example, let's look at what does k nearest neighbor stands for. Now k value is the one of the classification groups that I need to make using my algorithm. For example, if I give k equals to 2, I need to say that I give a classification classes of 2. If I give 5, I want my classification into 5 different categories. So once I have a distribution of different values according, what it does is it takes a specific value and closes and marks the nearby neighbors according to the same, and then classifies them under one specific category. By doing that, it takes the centroid and moves it around across as the value of the Euclidean or the Manhattan distance changes from one center point to the other distributed points in the given data. Now in this image we can see the number of k equals to 3, and let's see how do we handle the one in our given data set. So k nearest neighbor is been given the lazy classification name, as since it just simply uses a very basic strategy to compute the classification, as it simply says that by the time the data is being scattered over the plot, the one with the most familiarity will be the one in the specific category. That's the only approach that KNN provides and gives a successful result in classification. That's why it's known as a lazy approach. So let's get started with the data set that we have. So importing the necessary libraries and using the social network data for the purchase transaction that we had. So running the first 5 values for the same, the df.head provides us, if I change a value of by 10, it gives us the first 10 values. Similarly, if I do df.tail and then run it, it gives me the last 5 values. So as we can see, we have a total of 400 entries, and we need to calculate whether on the basis of the given attributes a purchase will take place from a user or not. So as we have discussed, we need to select only the necessary attributes in the given data. So that's why we have taken only gender, age and estimated salary in X and purchased in Y. Once that is being done with X and Y, we need to look into the model separation of the test and train split. So in this one, the test size we have considered is 20%, followed by giving 80% of the data for the training and the random state for having a same distributed value of the data in test train. Every time we take a random state of 42 in this one. It can be changed according to the user or any number that you like. So once that is done, we need to do the standard scalar transformation. Once we cross that, the pre-processing, now we need to call our algorithm, that is the k neighbor classifier. Now that is present inside a specific class provided in Scikit-Learn, that is neighbors, and inside that we have the k neighbor classifier. Now in k neighbor classifier, the number of neighbors that we have given is equals to 5. The metric is by default the Minkowski and p-value as given as 2. Once the default values are being provided, what we have to do is we just simply have to train the value which is given. So once we run that, our model gets trained. Once a model gets trained, we get the value of y predicted, and we can see the value of y predict. Also, the value of y test data that we early on distributed, like separated, for the comparison purpose of how much accuracy that we have obtained from our data. So once both of the factors are done, we have to see how well the k neighbor classifier has changed the value for the classification that we have asked. So taking the value of n equals to 5, we can increase or reduce the amount of reports that is been given to that. So currently we have taken 5, we'll be changing the value to see the difference in the results. So let's get with the confusion matrix, calling it from the matrices class in Scikit-Learn. We can see the correct predictions of 48 and 25. And a normal distribution of incorrect predicted value of 3 and 4 on the basis side. Now once if you see any of the much more incorrect values on either this side or this side, it simply means it's a bias. For example, if I was having a value of approximately 10 or 13 and 1 or 2, I simply mean that my model is having a bias because it's predicting a wrong value in a specific direction. Once that is done, let's look at the accuracy scores that we have. So we can see the accuracy score that we have is 91%, which is good, but let's see what we can increase it for the same. So if I reduce the number of neighbors and we do the confusion matrix, we can see now it's been given as 10, as the wrong values is being predicted in a specific direction. We can say that there is a chance that our model may got biased from the data, and see, because of that the accuracy also got reduced. Now let's see if we can increase the number of neighbors, and finally what does the result is being obtained. Now as we can see, we are having an almost equal and small distribution of error from the both side, and let's see how much accuracy score we obtain in that. So as we can see, we got now a score of 92%, which is much more better as compared to the 91% we received in n equals to 10. And that simply states that how the much number of neighbors that we provide to the model, the better results we get, since it distributes the number of segments into much more smaller and scalar, as making it into a complete classification class or a cluster. So that was k nearest neighbor as one of the laziest approach given in the machine learning, and the simplest one, still able to make his mark and provide us with a pretty good result scores. That's all for k nearest neighbor, and then I'll be looking forward to you in the next class. Thank you.